move on to lesson 2.5. Okay. And again, I said you need to go see your peer leaders because you have exam next Tuesday over chapter 2 because this is your last lesson. We're done. Okay. We don't have anything left in chapter 2. So make sure you see your tutors. Remember, you can reach out to any of them. Okay. But you do have your peer leader time, the session you're supposed to attend. So try to attend that. For whatever the reason you cannot attend those, then you can reach out to individual person like Wade or Quincy or Makaya and say, hey, can you help me? They will willing to help you. So reach out to them. Okay. All right, you guys, one more thing, one more housekeeping. I noticed that there's still a few people, I would say like 5 or 6 students still have not purchased WebAssign code. Remember your exam and your homework problems all in WebAssign. So you have to have those code. All right, and then all your homework is due by next Monday because you have an exam on Tuesday. So please get the code so you will not be behind. Okay, and you can use the same code to take your calculus too. So it's a good investment because you get to use for entire year, not just the one semester for one purchase you do. All right, you guys, let's go and move on to 2.5. Okay, anybody have any questions? Can I move on to 2.5? Okay, make sure that I am here so I can do your attendance. Okay, implicit differentiation. That's what we're gonna do. 2.5, implicit differentiation. So let me explain to you, okay, what's the difference between what we have learned and then what is implicit differentiation. All right, so today's objective, distinguish between function written in implicit and explicit form. So we have been looking at explicit form. Everything was starting with y equal to and then expression. All right, but today we're going to learn the case is not explicit. That case, it's easier to do implicit differentiation. All right, so use implicit differentiation to find derivative of a function. Implicit and explicit functions. Let's look at it. What's the difference between implicit and explicit? So most functions have been expressed in explicit form, which means you write down y equal to expression like this. All right, so we've been writing down as well y prime equal to say 6x. That's how you found your derivative. Remember, y prime is the same as what? dy dx. You're taking a derivative of a y respect to x because your right hand side is your x, your left hand side is y. You're taking your derivative respect to x. So, and now looking at this problem, if you have this problem, okay, I can rewrite it as x over divided by x, and you get a 1 over x, you get a y equal to 1 over x. So I can rewrite this kind of form, we call it implicit form. The implicit forms, I can rewrite it as explicit form. This is implicit. And this form is explicit. Okay. Explicit form means y equal to expression. And the right hand side is all x's. There's no y there. The left hand side is just y by itself. That's explicit. And then implicit means x and y is kind of mingled together, okay? So I can take a derivative of this using a explicit way. So which means you have this, you can rewrite this problem as this, and which that's same as x to the negative 1 power. And you can take a derivative, right? dy dx is the same as y prime, right? And you're gonna say one more power, so you get x to the negative 1 and x to the negative 1 times x to the negative 2 power, which is the same as this. All right, that's great. So yes, I can change some of implicit form into explicit form, but not always that's the case. For example, if I give you problems like this, okay, there is no way I can write this problem as y equal to, and then x on the right-hand side. Okay, let's try it. So if I decide to move this one to other side, then I have a negative 2y to the third plus 4y equal to 2 minus x squared. But now look at this, the right-hand side. Remember, we need to write that as y equal to something. All right, how am I gonna do? So this one, if I simplify this, I can probably put out 2 and y in the front, and I still have what? Negative y squared plus, so if I bring plus 1 equal to 2 minus x squared. All right, then there is no way, if I decide to put this one to other end, then I have negative 2y equal to 2 minus x squared over negative y squared plus 1. But look at this. I still have a problem. Okay, even I divided by 2 here. Okay, so I have there. But the right-hand side, okay, is not x by itself. I still have a y here. To be explicit form means y equal to, on the left-hand side, and the right-hand side is expression of x only. No, there should be no y there. But I cannot make that way. So the implicit differentiation is not possible in this case. So that is why we need to learn implicit differentiation. Because in this case, implicit differentiation is a better choice. All right, so we're gonna go over. So you know how to do, take a derivative of x to the third. You're gonna say 3 times x squared, okay? All right, so thinking is this. So if I give you y equal to x to the third, I can think of this as a dy dx is equal to 3x squared times dx dx. I can think of that way because I'm taking derivative respect to x. All right, then this just equal to 1, so that's equal to 3x squared. All right, so you can think of this way, writing, you're taking derivative respect to x, so I can say dx over dx. Okay, now looking at this, then if I give you, so say y equal to y to the third. Okay, you can think of that way, okay? This case, you're gonna say, okay, that means dy dx is equal to 3 times y to the second times. I'm taking derivative respect to x. So dy dx. Okay, so that's why you have this. So when you're taking a derivative of a y, is a dy dx. Over here, you're taking a derivative of this, you get a dx is 1 times dx over dx plus 3 times dy dx. But dx dx is the same as 1. That's why it's equal to 1 plus 3 dy dx. All right. Are you guys following me right now? Are you okay? All right, let's do this problem in a notebook so it'll be easier to see. So if I give you, say, dy dx is equal to x squared times, say y. I give you this problem. First thing first, I know I have to do what rule. So before with the implicit derivative, okay, since it's a multiplication, what do I need to use? Which rule? Constant rule, power rule, product rule, or quotient rule, or chain rule? What do I need to use? Okay, somebody tell me, what rule do I need to use? And tell me what is my first one? I call it this to be usually F, right? I call this one to be my usually a G. Then I'm gonna say, okay, my f, I'm doing a product rule right now, okay? So my f is equal to x squared, and f prime is equal to 2x. That's what I'm gonna do. Okay, I'm going to say g is equal to y, and g prime is equal to what? dy dx. All right, is everybody with me? So I'm gonna use a product rule, so I need to write down like that. So that is equal to, then I'm going to say f times g prime plus g times f prime. That's what I'm gonna do. So we just simply plug it in, what f is. So f is x squared, and g prime is dy dx, plus g is y, f prime is 2x. So I'm pretty much done. Okay, don't they have starting with some numbers? Because we're not doing the same problem, but anyway. So in this case, you cannot do any more, that's it. So you're done with this, okay? Let's look at other examples. Okay, let's look at problems like this. Okay, can somebody write this down for me so we can do this problem in a notebook? It's x to the third, y squared, minus 5y, minus x squared equal to -4. That's what we're gonna do in a notebook. Okay, tell me what's the problem? Y to the what? Okay, did anybody write this problem? Y to the what? Did anybody write down the problem so they can repeat back to me?
Y to the third.
I believe it was y third, yeah.
Y to the third. What's next?
Plus y to the second.
Second.
Minus 5y.
Minus 5y.
Minus x squared.
X squared.
I didn't get the last part. It was plus or minus 4 though.
Okay, 4 is fine. All right, so we have this problem. Does everybody agree I cannot do explicit differentiation because its y is all over the places? Okay, in this case, the best thing to do is what? Implicit derivatives. Okay, so let's do that. First thing first, I'm gonna do one at a time. So this right here, taking a derivative of that, I'm just gonna use a simple power rule. So that means 3y squared, and then what? I do dy dx. So whenever you take a derivative of a y, it's always dy dx. Write down like that so you can clearly see. All right, now let's do the second one. Take a derivative of this one. Again, we're gonna use a power rule. So that's equal to 2y dy dx. All right, now let's take a derivative of the third one. Right here. So that's one just simply -5 what? dy dx. All right, and then last, I'm gonna do one more. Take a derivative of this. That's again power rule. I'm just using a power rule for each term. Are you with me? It's not hard because I'm just simply using a power rule for each term. So it's a simple problem, but it's long. So that'll be 2x dx dx. Okay, now that's equal to, everybody knows what this is equal to, right? What's the derivative of a constant? Simply 0. So now I need to do some manipulation, algebra manipulation. By the way, this just equal to what? 1, right? dy dx is the same as 1. So let's just rewrite this problem. Well, I don't think we even have to rewrite it, this problem, because just look at this. I want dy dx to be left-hand side. Everything else needs to go to right-hand side. Are you with me? I want dy.
These pairs.
Yes.
Okay, you see how you got 2x dx over, or is it dx over dx?
Right.
Okay, so if it was x to the like third or something, what would it be?
I would do 3x squared and then what? Y dx. When you take a derivative of x, it's dx over dx. That's why it's always equal to 1. Then we usually skip that part. We don't write down dx over dx because dx over dx is equal to 1. But I just write it down for you. So that's what really means. But if you choose not to write it down, that is also fine. If you, oops,
Okay.
not so sure what I just did. Okay. So if I choose not to write down this part right here, okay. Okay, I need to rewrite this problem right here because it's a little bit messed up. Okay, so I got this part. Okay, class, I'm gonna just do it again because it got messed up right here. Well, we get to practice one more time. I'm gonna write down my problem again. Problem is y to the third plus y squared. And what's my next one? Does anybody remember?
Minus 5y minus x squared equals
Thank you, thank you. All right, let's do this problem again. Sorry about that. Something just happened. So let's do it one more time. We get to practice, okay? Everybody write this down on your notebook too, so we can do it together. So we're gonna take derivative one at a time. So let's take a derivative of this. So everybody agree, using a power rule, 3y squared, and then what do? dy dx. Because whenever you take a derivative of y, you're gonna put dy dx. All right, second one, the AVN. What's the derivative of this one?
2y dy over dx.
That's right, 2y dy dx. All right. Pyron, what is the derivative of this? Negative 5y. Pyron, are you here? I thought he was here. All right, Steph, let me ask somebody new. Shalia, can you help me? What is the derivative of negative 5y?
It'll be 5 times dy over dx.
That's right, negative 5 dy dx. Thank you. Next one. I'm doing all this -2, negative x squared. So Thomas, what is the derivative of negative x squared? Thomas, you need to unmute it. I cannot hear you. What's the derivative of negative x squared?
Is it a 2x?
So negative, it's negative sign, so negative 2x, great. Okay, next one, that's the easy part. What is the derivative of that? Stephanie, what's the derivative of 4?
0.
Right, constant rule, always 0. All right, now, my goal, taking an implicit derivative means you want dy dx to be in the left-hand side, everything else goes to the right-hand side. So first thing first, I'm gonna move 2x to other side. Okay, so then I have 3y squared dy dx. I have 2y dy dx. And I have a negative 5 dy dx. This cancel out. So I have 2x on the right hand side. All right, everybody good? Now, look at the left hand side. What is the common term that I can factor out? Look at the blue, look at the red, look at the green. All those terms, what is a common factor that can bring it out? Dy dx, right? So I'm going to factor this one out. Dy dx, dy dx, dy dx. I'm going to bring out to the front. So I have my common factor dy dx. And then I'm left with 3y squared plus 2y minus 5. Everything equal to 2x. Remember, I want dy dx by itself. So what do? Of course, I just what? Divide everything by what? Exactly same thing, isn't it? Okay, so now I'm done. So my answer is dy dx is equal to 2x everything over 3y plus 2y minus 5. Dy dx. So dy dx is same as y prime. So that's your answer. So when you take derivative of this implicit, when you take implicit derivative of that become this. All right, class? All right, let's do another problem because we're done. This is what we need to do today. So let me just give you one problem and see how you're gonna do. Actually, we can look at one of their example if you want to. Okay, they have this kind of complicated problem right here. Okay. Okay, let's do that problem. Can somebody write this down so we can do it together? Okay, 3 times parentheses x squared plus y squared, everything to the square power equal to 100xy. So write that down so we can do this problem together. That's the last lesson for today. And then I'll just give you some homework, we can go over some homework problems. Okay. Ethan, did you write this down so you can repeat back to me?
No, ma'am, I'm still writing it down.
Write this down so you can repeat it back to me. You good?
I got it.
All right. Okay, what's the problem?
3 open parentheses x squared plus y squared close parentheses to the second power equals 100xy.
Okay, this is my problem. And we have to take a derivative of this. So the thing I can really do at this point is definitely I can only do what? Implicit derivative. There's no way I can do other than implicit derivative. So this is a complicated problem because we gotta use chain rule. We have to use product rule. The left-hand side, you need to use a chain rule. The right-hand side, you have to use product rule. Does everybody see it? Okay. So I expect you to remember your product rule. So I'm gonna just go ahead and do it, okay? Just remember the product rule. So let's do the left-hand side first. So left-hand side, the chain rule. So you're gonna use a chain rule. So I'm gonna say u is equal to what? X squared plus y squared. So you're gonna say, okay, u prime is equal to then what? 2x plus 2y dy dx. So we got that. I'm just gonna write this down so you remember, okay? And then you're gonna say because we have to do a problem at a time. So I'm gonna also say, okay, I'm gonna call it this to be my f. This to be my g. Then you're gonna say f is equal to x, f prime is equal to 1. Oops, I used the wrong color. Okay. So I'm gonna use, what color did I use? Red one, okay. Red one is f. So f is x, f prime is 1. I use a g to be y, and g prime would be what? dy dx. Okay, remember this? So we got our preliminary work. Okay. So now, then I'm gonna rewrite this problem. This problem right here become 3u, let me just use a yellow color, I mean the green color, because u is a green. So I have a 3u squared is equal to 100xy, okay? Because I'm doing a chain rule. So remember, I'm using a chain rule here. And over here, I'm using a product rule. Okay, I'm using two different things. All right, so now, so if I use the chain rules, I can just say, okay, that is same as 3 times 2 times u to the 1 power, and then what? U prime. Okay, that's equal to, and then you're gonna use a product rule on the other side. So say, okay, the product rule says 100. Don't worry about the 100, just leave the 100 in the front. And I'm going to parentheses. The product rule says what? F times G prime plus what? G times F prime. So that's what I need to do. So F is X. Okay, what is G prime? dy dx. Okay, and plus G, which is y, F prime, 1. So that's what you have. Okay, right hand side, I'm done. Now look at the left hand side. Left hand side, I need to put back the u in terms of x and y. Okay, so I'm going to replace u. So it'll be 6. 3 times 2 is 6. And my u is the same as what? X squared plus y squared. What's my u prime? U prime is this, which is 2x plus 2y times dy dx. Okay, this is a very complicated problem. That's equal to that. We have a 100 x dy dx plus y. Okay, now the calculus part is done. Now I got the algebra part. So which means I need to multiply them out. Okay, just simplify this. So whatever the reason you stopped it right here, I will still give you 5 out of 10. Because you have done, you done the calculus part. Now you got the algebra part. Okay, so let's do algebra part. So, okay, gonna say, okay, looks like to me I have to do what? I do need to do, okay, so for now, the left-hand side, I'm not gonna do anything yet, but I'm gonna do the right-hand side. I'm gonna expand my right-hand side. That's what I have. 100x dy dx plus 100y. That's what I have. Okay. Now you're gonna tell yourself, okay, I have to make dy dx to be one side. I cannot do that yet because I see dy dx over here. And I have dy dx over here. So I cannot combine them yet. So right now, what I need to do is I need to FOIL this. I'd rather not, but I have to, otherwise I cannot combine dy dx by itself. All right, so I will FOIL this. And if you want to, you can divide it 6 now for every one of them. So you don't have to worry about the 6. Okay, then just let's FOIL it. Then I have x squared times 2x, which gives me 2x to the third. X squared times 2y dy dx gives me 2x squared y dy dx. Next one, y squared times 2x gives me 2x y squared. Y squared times 2y dy dx gives me 2y to the third dy dx. Okay, we're almost done. This is just the algebra part. So now I'm gonna move, anything is not with the anything does not, any term does not have a dy dx, I will move to the right. So it looks like to me, this is only term does not have dy dx. So I move that to other side. Okay, and now look at the right hand side. The right hand side, anything with a dy dx, then you just go to the left hand side. So I'm going to subtract 100x over 6 dy dx. Okay, so that cancel out, that cancel out. So I have 2x squared y dy dx plus 2x y squared dy dx plus 2y to the third dy dx. Remember this one. So 100 x over 6 dy dx. That's equal to that, which is 100 y over 6 minus 2x to the third. A little bit complicated, but as I said, it's just the algebra, okay? You just need to do algebra slowly. Now look at the left-hand side. Everything has a dy dx, so I can factor that out. So this, there's a dy dx, dy dx, dy dx, dy dx. So move that into the front as a common factor. And I am left with 2x squared y plus 2x y squared plus 2y to the third minus 100x over 6. Everything over 100y over 6 equal to 2x to the third. All right, now what I do, my last thing. Since I want dy dx by itself, so I will just what? Divide everything by this. I'm just doing the same thing, just repeat it, okay? Same thing. Then you have your answer. It's a bit complicated, but that's your answer. On your exam, I try not to give you this kind of complicated problem because I don't want you to spend all your time doing this. So that's your answer. That's your implicit derivative. This is not, by the way, completely simplified. If it's completely simplified, then I need to, what is 100 divided by 6? Whatever that number that is, you can rewrite that as some number, whatever that is. But this is good. Okay, now let's go ahead and look at some homework problems. So we get to practice. Okay, I'm gonna look into 2.5 homework with you just to make sure that I'll go over some of your homework problem. Okay, as you see, 2.5, I only gave you 5 assignments. You see it, only 5? Because it takes a little bit of time, okay? That's the reason I gave you. So let's look at this problem. So I'll write down over here. So 4x squared minus 5y squared equal to 25. This is easy for us because we know how to do this kind of problem. It's a very simple one. Because I'm not using product rules, I'm not using chain rules, I'm only using a power rule. Does everybody see that? Look at this problem. We're only using a power rule. All right, so now look at this problem. So we're gonna look at one at a time. What is the derivative of this? That'll be, you're gonna say 4 times 2 times x to the 1 power. Okay, and what's the derivative of that? And you're gonna say that's the same as negative 5 times 2 times y to the 1 power dy dx. The last thing, what's the derivative of this? It's just simply 0 because it's constant by the constant rule. All right, let's just simplify it one more time. 8 times 2 is 8x. 5 times 2 is a negative 10y dy dx. That's simply equal to 0. As we said before, it does not have a dy dx. Any term does not have a dy dx. That means it goes to the right-hand side. So I'll just go and move. Okay, so now I'm just left with negative 10y dy dx equal to negative. Okay, now I'll divide it by what? Everything by negative 10y. So I'm done. dy dx equal to 8x over 10y, or I can say over 5x over y. So that's why you have answers right there. Remember, negative and negative makes positive, right? Negative 8, negative 10 gives you positive. That's why 4 over 5. So this is one way you can do it. So this is an easy problem. So I will probably give you problems like this that you can do right away, not using a chain rules and product rules, not so complicated on your exam. Because I don't want you to spend too much time just trying to do it. If I do give you a complicated problem, that means I will give you less problem. Instead of giving you 10 problems, I may just give you 5. So next Tuesday, I will give you actually 90 minutes, not 60 minutes, because because you have to show your work and email to me or text to me. So I'm gonna give you extra 30 minutes. So this exam on Tuesday, you have 90 minutes. And I haven't decided how many. I made it 10 problems, but I may give you a little bit less. So you have plenty of time to do your work. So let's look at the number 3. So you can look at the trigonometry functions. Okay, number 3. So we're gonna do this problem. So we have 2 cosine 4x sine 4y equal to 7. So we're gonna use a product rule. Okay. So let me just divide it by 2 first here, because I don't want that number to be right there. So I have then cosine 4x and sine all right, that's what we have. Now we have to do a product rule. Does everybody see that? It's a product rule I gotta do. It's multiply by that. Not just that, I also have to do u substitution, but I'm not gonna do u substitution. I just want you to remember taking a derivative of this. Remember that, okay? Take a derivative. So first thing first, let's just go ahead and do it without writing down, okay? Because I expect you remember now. So first thing first, I'm gonna write down cosine 4x, and I gotta write down what? Derivative of, I need to find the derivative of that. So what's the derivative of a sine? That's also cosine 4y. And now I gotta take a derivative of u, this one, derivative of 4y, which is what? 4 dy dx. Do you see it? Do you see what I just did? This is what I'm doing. F times g prime plus g times f prime. That's what I'm doing. So I just finished this part. Next one. Plus sine 4y. Now this time let's take a derivative of this one. Take a derivative of a cosine, which is what? Negative sine 4x. Remember to take a derivative of a 4x. What's the derivative of 4x? Simply 4. Okay. Now take a derivative of the right hand side. Derivative of a 7 over 2 is simply 0. Okay, are you with me, guys? Okay, now remember we're gonna put everything else to the right hand side if it doesn't have a dy dx. So this term right here, so I just need to move this one to other side. I'm just gonna simply put the negative of that. I'm gonna do exactly the same thing. So I'm left with cosine 4x and cosine 4y or dy dx equal to this expression, which is, by the way, negative here. When you move to the other side, and this is negative, negative. So because of that, it become a positive here. I'll just put the negative so you guys not get confused. Negative sine 4y, negative sine 4x, and 4. You know what, let me just do this in notebook because it's very complicated here. You cannot see everything. Let me just do that in notebook. So you know how to do that problem. So problem is what? 4 sine 4x cosine 4y equal to 7. All right, so I want you to think about the product rule. Okay, so if you want to, let's do it. Since we got more space, I will not skip step. So I will call it, oh, excuse me, that was 2, wasn't it? It doesn't really matter, but it's a 2 right here. So I told you I'm just gonna do divided by 2 first. So my problem will be a little more simplified. So I have sine 4x cosine 4y equal to 7/2. Now, I'm going to call this first thing over here, I call it f. I'm going to call this my g. So I'm not skipping steps, you guys, so you can see what I'm doing. So f is equal to sine 4x. So f prime is cosine 4x times what? Derivative of this. Let me use green color. Derivative of this 4x, which is simply 4. Okay, next one. I'm going to call it y is equal to the g is equal to cosine 4y. So g prime is equal to negative sine 4y. Now, again, I'm using a chain rule. So derivative of 4y, what's the derivative of 4y? That's the same as 4 times dy dx. Is everybody with me? Are you lost? Are you with me right now, class? Show me if you understand, say yes. Okay, are you with me?
Yes.
Great, thank you, Stephanie, for giving me assurance. Okay, so everybody see that I'm not just using a product rule, but I'm using a product rule and then also a chain rule because it's 4x. I got to take a derivative of 4x, take a derivative of 4y. That's why I have this green writings over here. Those are the chain rule came from. All right, now let's do that. So we know our formula. The formula says f times g prime plus what? G times f prime. That's what I have to do. So I'm going to plug it in. F, which is sine 4x, g prime. G prime is negative sine 4y times 4 dy dx. Okay, and plus g, which is cosine 4y, and f prime, which is cosine 4x times 4 and then equal to just a 0 because 7/2 derivative of a number is a 0 always. And then you're going to say, okay, I want the one does not have dy dx to move to other end. Okay, then you're going to say, okay, looks like to me this part does not have a dy dx. So I'm going to subtract. Same thing. Cosine 4y, cosine 4x, 4. Subtract cosine 4y, cosine 4x, 4. Okay, so you know that cancel out. So now I have sine 4x, negative sine 4y, and 4 times dy dx is equal to simply that. Negative cosine 4y, cosine 4x. Can I put the 4 in the front now? Okay. So now I'm done, pretty much done. Did this 4 and that 4 cancel out? And then I'm going to also divide everything by this, which is, you got negative in the front. Can I put the negative in the front? So negative sine 4x sine 4y. negative sine 4x sine 4y. I'm done. I'm finally done. So my answer is just simply what? You cancel out. So that is your answer right here. dy dx is equal to cosine 4y, cosine 4x, everything divided by negative. By the way, this negative and that negative cancel out. So just the positive sine 4x times sine 4y. That's your answer. Okay. So you're done. All right, that's today's lesson. So I'm done. Lesson-wise, is everything is done. So anybody have any questions from previous homework problems that you need to go over? Does anybody have any questions? You want me to just go over some problems with you guys instead of you choosing problem?
Yeah.
Okay. Let's look at problem from lesson 3, because lesson 3 has a complicated problem. You have a product rules. Product rule and the quotient rule. Let's practice quotient rule. I feel like we haven't done enough quotient rule. In fact, I didn't give you that many quotient rule, isn't it? So number 7. Okay, I'm gonna do number 7, sine t over t. So that's what I'm gonna do with you guys. So this is 2.3, number 7 problem. So y is equal to sine t over t. So I want to take a derivative over this. Okay. The quotient rule. So we're gonna call it. I'm gonna call this to be my. I'm gonna put this to be my f. I'm gonna call this to be my g. So quotient rule is. What's the quotient rule says? Anyway, let's do that first. Just write down all the things we're supposed to know. So we're gonna say, okay, my f is sine t. My f prime is what? Cosine t, simply cosine t. My g is t, so g prime is simply 1. All right, now next thing. So you're gonna say dy, what do I put? Do I put dy dx or do I put dy dt in this case? India, what do I put on the dy?
Is it dt?
Yes, because my right-hand side is an expression of what? T. So you're taking a derivative in terms of respect to what? T. That's right. So, or I can rewrite as y prime, right? Which is fine. And then what is my formula for the quotient rule? Quotient rule says what? F times g prime minus g times f prime, everything divided by g squared. That's your formula. So I'm going to say, okay, dy dt is equal to, plug it in. So that'll be sine t, and g prime happens to be easy 1, so it's equal to 1, minus g, which is t, times f prime cosine t, everything divided by g squared. So here I got t squared. So this is just happens to be an easy problem, and we're done. That's it. So my answer is y prime is equal to sine t minus cosine t, everything divided by t squared. That's 2.3, number 7. That's what I just did. All right. Any other questions that you want me to go over? Let's just see your homework problem again. Did I not put the T? Let me see. Where's my file? For whatever reason, the problem I just did is not there anymore. But anyway, you know how to do. So that was not a hard one. Okay, so now (2.4), some problem from 2.4. I'm trying to see anything that's really hard. But like number 10, I gotta use a product rule and a chain rule. So let's look at number 10. Number 10. So we have a problem f is equal to x times 3x minus 9, the third power. This is a product rule and a chain rule that we're gonna use, okay? All right, so I'm gonna call, I'm not gonna call this to be f because the problem is already f. So how about I call it h? I'm gonna call this one my h. I'm gonna call this one to be my g. All right, is that okay with you? Because it doesn't matter what variable you use. I just need to have first function and second function. So my h is x, and h prime is equal to 1. Next to my g is equal to 3x minus 9 to the third power. All right, does everybody see I have to use a chain rule for the g? All right, so I'm gonna say, okay. So g prime is equal to 3 times 3x minus 9 to the second power, but I'm not done yet. Why not? I need to take a chain, derivative of the chain one, right? The second inside of that, what is my derivative of the 3x minus 9? And you're gonna say that's equal to simply 3. Does everybody see that? So I'm using a product rule and a chain rule. So you're gonna say, okay, now let's go and finish this problem. So this f, that means I'm gonna do h times g prime plus g times h prime. That's what I need to do. So f prime in this case is equal to, so I'll write it down, x times g prime so 3, so I'm doing 3x minus 9 to the 2 power times 3 and plus g, which is 3x minus 9 to the third power times h prime 1. So we're pretty much done. This is a simple problem actually, compared to a lot other problem. I'm gonna combine 3 in the front, so it'll be 3x minus 9 per square plus 3x minus 9. So I'm done, but if